This is the class activity, work and power problems. So we're going to be doing some practice problems involving work and power. So the purpose of this activity is to practice calculating work and power. And you can see in the references, of course, what I'll do is I will post this video, but I also posted there are some links to work, energy, and power, and work and energy, just little things to help you practice calculating them if you need to review that. And of course, always off to the side, I always do post the equation. So you do have the equation for work, which is force times distance, and a triangle that you can use. And then there is the equation for power, which is work divided by time. And of course, I do have that triangle. So you just practice, you cover up what is unknown, and then it leaves you with that equation. So let's just start this activity. So the guided practice. The first few problems just help you out, help you organize your thoughts. And of course, here there is a checkbox to generate problems. I'm just going to check that box, and now I've got a list of problems. So let's take a look at problem number 1. If a group of students can apply a force of 19 newtons to move a crate 25 meters, how much work will they have accomplished? So first thing that I want to do is I want to just plug in I want to plug in the known variables. So they apply a force of 19 newtons. So I come in here and put 19. The unit is newtons. There we go. To move a crate 25 meters, that is the distance. You have 25 meters. There we go. I know that's correct. Now I can determine what the equation is. How much work will they have accomplished? And that hint is going to tell me, right? Cover up the unknown variable on the work triangle to find the equation to use. The unknown for this problem is work. So I cover up work on the work triangle, and it's force times distance. So I can put that equation down there. Work equals force times distance. So now I know the equation to use for work, right? To calculate work, force times distance. So in this problem, what I do is I'll put this screen up here. I'm going to take the force, which is 19 newtons. I'm going to multiply it by 25 meters. 475 joules. Joules of work was done. Right, so notice everything, you have to get the value and the unit correct for it to turn green, and I get a point once I get the whole problem. So I'm going to skip down to number 3 because this is work and power. So let's take a look at number 3. How much power is delivered in 10 seconds if it takes 13 joules of work to lift a box from the ground to the table? So let's just plug in what we know already. So we have time is 10 seconds. All right, that is good. We have 10 seconds. 13 joules of work. So I got 13 joules of work. There we go. Now, what this is asking me for is how much power. So I look at my little hint. It says cover up the unknown variable in the power triangle to find the equation to use. The unknown for this problem is power. So I come down here and I click, and I have, let's see here, power equals work divided by time. Right? So that's the equation that I'm going to use. It's very helpful because, well, it turns green when the equation that I use. So now I can plug in my known variables into the equation. So I'm going to come over here to this calculator. I'm going to clear everything out, and I'm going to take the work, which was 13 joules, divided by the time, which was 10 seconds, and I get 1.3 watts. 1.3 watts. There we go. So now it's correct. It turned green. There are 2 more in this guided practice, and then the rest of the problems, it's up to you to use the triangle, the equations, keep track of your known variables, and solve for the unknown. So once again, this is the class activity, work and power problem.